Hey everyone, welcome back. This is Maddie. In this video, we'll be seeing our first array problem. The problem is we are given a sorted array something like this 0 0 1 1 1 2 2 3 3 4, and the ask here is to return the number of unique elements. Let us see how we can find out an unique elements in an array. The first approach is I'll just write the array 0 0 1 1 1 2 times 2 3 2 times 3 and then 4. What we can do is, here if you closely observe, for each array either the first index or the last index element will be unique. Either of them, even if they are same, they will be unique, right? Let's take, we have an array like this. Either first index element or the last index element is unique, right? It goes that way. Either the last index or the first index element will be always unique. In this case, let us consider the last index element is unique. So what we can do is, we can start our loop from this point and loop until the 0th index and find out whether it is unique to the next element or not. Let me dry run it. I'll repeat the array for your understanding purpose. 0 2 times, 1 3 times, 2 2 times, 2 times 3, then 4. We can have a length variable initialized to the capacity of the array initially, which is arr.length. I'll just write the indexes as well. As we have discussed, we'll be skipping the last index. As we know, either first index or the last index will be always unique. So we'll start our loop from this index, meaning 8th index. Now we'll have a if condition to check whether the current element is equal to the next element. Is it equal in this case? No. In this case, we won't be doing anything. We'll just decrement the index to the 7th index. We'll check the same condition again, whether the current element is equal to the next element. In this case, yes, 7th index and the 8th index are same. What we can do is, we can run one more loop to delete them. But the question here is to return only the unique elements, number of unique elements. So we won't be performing delete operation here. If they are equal, we can just reduce the length variable by 1. Now length will become, initially it will be 10, it becomes 9. After decrementing, the flow goes to 6th index. Check the same if condition, whether the current element is equal to the next element. In this case, it is not equal, they are different. We won't do anything in this case. Now the flow goes to 5th index. Again, the same if condition is checked, whether the current element is equal to the next element. In this case, they are equal. What we will do is, we will decrement the length variable by 1. 9 becomes 8. Now flow goes to 4th index. Checks whether the current element is equal to the next element. In this case, they are not equal. So we won't be performing any operation. Now flow goes to 3rd index. Same if condition, whether the current element is equal to the next element. In this case, they are equal. Decrement length variable by 1, which becomes 7. It again goes to the next index. Again, same if condition, check whether the current element is equal to the next element. They are equal. Since they are equal, we'll be decrementing a length variable by 1, which becomes 6. Again, flow goes to the first index. Same if condition is checked whether the current element is equal to the next element. They are not equal in this case, so do nothing. Then flow goes to the 0th index. Again, same if condition, check whether the current element is equal to the next element. They are equal, so we will be decrementing a length variable by 1, which becomes 5. Now flow will not go to the -1 index because we will be having a condition where for loop should run until the index is 0. Since the index is -1, which is not greater than or equal to 0, our for loop ends here, and at the end we will be returning the length variable as an output, which is 5 in this case. Are there only 5 unique elements? Let us count them. 0, 1, 1, 2, 2, 3, 3, 4, and 4 is unique, 5. Yes, we have only 5 unique elements. You may be thinking that why we are starting the for loop from length -2 index. I'll also show you what happens if we start the for loop from the first index and check whether it is equal to the next element or not. I'll show you that in code. What happens if we start for loop from the first index and check whether it is equal to the next element or not. I hope so far the things are clear. Let us see how we can write the code for this. Let me just switch my screen. I'll just write a method over here, public static. As we have seen in the notepad, we will be returning a length variable which is of type int. So the method return type will be of type int. Return unique, which takes in array as a parameter. We'll be having a length variable initialized to the capacity of length initially. So we'll start the for loop. I equals length -2 and loop till it is greater than or equal to 0. Increment after every iteration. Check whether the current element is equal to the next element. I'm not doing anything new here. I'm just writing whatever we just discussed in the notepad. If they are equal, then we will be decrementing a length variable. After the for loop, we will be having an output in the length variable, so we can directly return length. I'll just create a main method, declare array. I'll just take the same example, 2 times 0, 3 times 1, 2 times 2, 2 times 3, and 1 times 4. Since our method is returning an output, we need to print it. Return unique, which takes in array. Let me run this program. It's returning answer 5. As we have just discussed in our notepad, it's returning the answer properly. I've also mentioned that what if we start an index from 1 instead of length minus 2? I'll just copy the same method, return unique 1, start index from 1, go till capacity. After every iteration, we'll be incrementing. We use the same if condition. If I call this method, let me run and show you what happens. Just comment this out. Ta-da! Array index out of bound exception. Why? Since we are using I plus 1, it is checking more than a capacity. We have already discussed an array cannot contain more than its capacity. Since we are accessing the element which is not at all present in the array, it is throwing array index out of bound exception. So that's the reason we are starting from the last and looping till the first element. Since we are using I plus 1, we need to start from the last to first. I hope this thing is clear. Let me just go back to notepad. Now the second point is, what if the ask is to return the unique elements instead of number of unique elements? What if the ask is to return the unique element itself? Meaning in this case, our program should return 0, 1, 2, 3, 4. This should be the output. How can we do that? Let us see. Since we need to return an array elements which are unique, we need to use an extra array here. Without that, we can't return a result. Let us see how we can build the logic for this. To declare a new array, we need the capacity of the array, right? Without the capacity, a array can't be declared. For that, what we can do is, we can use our first approach and find the number of unique elements, and we can use that length to declare a new array. Int result equals new int of, we will just be using the same value here, 5. In the code wise, we can use our previous approach to find this number. After the new array is declared, what we can do is, I'll just show you. Zero, 0, 3 times 1, 2 times, 2 times, and then 4. Let me just write the indexes as well. Again, to fill out the new array, we will be starting a for loop from this. Initially, we will be inserting this unique element to the result. How we can do that? We can easily insert result of, not array, result dot length minus 1 equals arr of arr dot length minus 1. This actually returns element 4, and this index takes in the new element, meaning first unique element. We'll start the for loop from the 8th index. Check whether current element is equal to the next element. They are not equal. If the current element is not equal to the next element, we were not doing anything, right? But in this case, what we will be doing is we will be inserting a new element into the new array, meaning resultant array. What we can do is result of unique index minus minus equals ARR of I. What is this unique index? This is nothing but the number of unique elements. I hope this thing is clear. If you have any doubts, please do comment it. We'll try to answer all of those things. We have inserted 3 to the resultant array. The flow goes to the next index, meaning 7th index. If condition will check whether the current element is equal to the next element. They are equal. We won't be doing anything. We have already inserted the same element into the resultant array. So we won't be doing if they are equal in this approach. Now flow moves to the 6th index. If condition will check whether the current element is equal to the next element. They are not equal. So insert into resultant array. Let me just write down the resultant array itself. Resultant equals, initially it will be having 5 elements, 0, 0, 0, 0, 0. Again, don't ask me why you are filling up zeros. We have already discussed all of these things in our previous video. If you have not watched, please do watch it and come back. Our first thing will be 4. Then this takes in 3. Now in the 6th index, the current element is not equal to the next element. So we are inserting the current element into the resultant array. Since the unique index is getting decremented, we will be inserting the element from the last. Now flow goes to the 5th index. Check whether the current element is equal to the next element. They are equal. Then do nothing. Flow goes to the 4th index. Check whether the current element is equal to the next element. They are not equal. So insert an element into resultant array. Since we are using decrementer here, it will always insert from the last. Flow goes to 3rd index. Check whether the current element is equal to the next element. They are equal. Do nothing. Flow goes to 2nd index. Check whether the current element is equal to the next element. They are equal. No operation will be performed. Flow goes to the 1st index. Check whether the current element is equal to the next element. They are not equal. So insert an element into it. Since we already have 0, in programming language, it gets overridden with the same value. Now flow goes to the 0th index. Check whether the current element is equal to the next element. They are equal. So we won't be doing anything. Now loop variable gets decremented to -1. But the condition will check whether -1 is greater than or equal to 0. That condition will become false. So for loop ends there. After ending the for loop, we'll be returning the resultant array as an output. I hope the things are clear so far. Let us see how we can do the same thing in the code. Let me just switch my screen. Close this. I'll just copy paste the same method. And change the return type from into integer array. We'll be calling our previous method to get the number of unique elements. Return unique array. Okay, this returns, let me just rename it to unique index itself. Rename this with arr.length. If they are equal, we should not do anything. we need to insert into resultant array only if they are not equal. Unique index, oh my bad. Yeah, we have not declared a resultant array yet. Int result, this should be after getting number of unique elements, equals new int of unique index result of unique index minus minus equals arr of I. We just need to insert the current element into resultant array, return the resultant. Let me just print this resultant array before modifying it. Result before modification. Why I'm printing is you can understand the things clearly. Arrays dot toString of result unique. This gets the number of unique elements. We are declaring a result array, printing it, and we will be populating the resultant array with unique elements, and at the end we are returning the result. Yep, we are good here. Let me just comment this out, s out. Since it is returning the array, I need to print it unique array which takes array. Let me run this program. It's throwing array index out of bound exception in line number 26. Let us see why it is throwing. We have unique index as 1, 2, 3, 4, 5. Okay, here is the issue. We need to decrement it before insertion. Because in this case, what it was doing is it was trying to insert an element into the fifth index. Since we have indexes from 0 to 4, it was not able to find the fifth index, so it is throwing array index out of bound exception. Let me run it again and see whether this gets resolved or not. Yep, it's resolving, but the output is wrong. Why is that? We have not inserted the last element into the resultant array. Result of result dot length minus 1 equals arr dot length minus 1. Since we are inserting an element into resultant array, we need to decrement it. Let me run it again. Yep, now it's returning the proper output. Let me just go back to Notepad. I've covered both the approaches. So far, I hope you have understood both of these two approaches. Wherein in the first approach, we did in place operations to return the number of unique elements. But in case of second approach, the ask was to return the unique element itself instead of the number of unique elements. In that case, we need to use an extra array to capture the unique elements. Now let us see when we can use in-place array operations. It's very important to know this. When to use in-place array operation. It's very important to know when to use in place array operations because they might not always be the way to go. For example, if we will need to return the original array later, then we should not be overwriting them. In these cases, it's best to create a copy of array to work with or to simply not use in place technique itself. When original need to be used later part in the process. It's important to be very careful when working with existing code that somebody else has written. If other code is depending on the original array to work, then you might completely break the program if you modify that array because Java is a pass by value. If you have not seen my pass by value video, please do watch it and come back to understand why in place array is very dangerous if we are working with the code that somebody else has written and if other code is depending on the original array. In place operations are valuable when appropriate because they reduce the space complexity. As we have seen, it will avoid the extra space in the programming languages. I hope so far the things are clear. In the next upcoming video, we will be shortly discussing a key feature and limitations of array, and then we'll move on to strings. How strings works internally in Java, how we can play around with strings, all those things we'll see in the upcoming videos. Thank you all for watching. See you in the next one.